All right, so good. Right, so as I said, we have this correlation value R that lies between -1 and 1. Right, is it being recorded? Right, good. As we said, 1 is very, very highly positively correlated, right? This means directly correlated, and this means negatively correlated or inversely related, right? Right, and we looked at the formula that they use to find R. Today now, we want to move on. We want to move on from the correlation value to doing a scatter plot like what we have here, then obtaining the regression line. All right, so you want to move on to get a scatter plot and then get the actual regression line, right? So here's what we're looking at. I may give you a set of X and Y values. Remember, as I told you, X is your independent value, Y is the dependent value, right? Y is dependent on X, right? So let's say I gave you some values, and then I asked you to do a scatter plot, right? So a scatter plot is very simple. All we're doing is that we're plotting just like at a point, plot the X and Y values. Right, and then before you do a regression line, right? Because you want to get a best fit line, right? So your best fit line might have a few options, right? Could be there, could be down a little more, right? But that's basically what your regression line will look like. But there's a very important property that we need to do in order to get this regression line. So let's say we had the one from before. To plot this regression line, right? To plot this regression line, we need something very important, right? We need a particular point. That point is your mean, X bar, Y bar, right? The regression line must pass through X bar, Y bar, right? Just to remind you, X bar is the sum of X on N, Y bar is the sum of Y on N. Okay, so make a note of that, please. Very, very important when they ask for the regression line, that you know what is X bar, Y bar, right? And you plot that point and make sure your regression line passes through there. Cause you can pop in real nice. All right, nice. Anybody writes in there? Right, anybody write in? No? I'm moving on, right? All right, so nice. So how do we get this new equation now? Are you listening, right? Very listening. All right, nice. So the regression, the equation of the regression line. So everything I'm showing you here is for the regression line Y on X, right? So let's do a quick recall. right? So remember the equation of a line. Equation of a line is of the form y is equal to mx plus c. So our regression line will resemble the same thing, right? So the regression line is of the form, same principle, y is equal to a plus bx, right? B, right? B is just like a gradient, but it's called your coefficients of regression. And A is same thing, right? A is your y-intercept, right? So how do we get these things? To get B, right, we use SXY, right, all over SXX. And to get E, I'll write it on this side, we use Y bar, B, and X bar, right? That's the way we get E. Right, I'm gonna just write back a formula for SX for you. All right, right here, right? Sum of X by sum of Y on N. Right, and how you get SXX? Same thing, sum of X squared minus the sum of X all squared on N. Right, copy that down. Copy that down. Right, so to get B, you're using SXY and SXX, and to get A, you're using your Y bar and your X bar, right? And B, and you're substituting that little formula I gave you there. Remember, this is for, where is my pen? This is for the regression line Y on X. Right, as I told you last week, this regression line could be used as a predictor. So if we know a value for X, we could predict what the possible value for Y will be. Right, copy it down. I don't really remember how to do it, but you all could Google how on the calculator you can get a regression line, right? Right, anybody writing? Wait. Right, so remember, when we use Y on X, the question will say, well, okay, find Y on X, or they will tell you that X is the independent and Y is the dependent variable. Right? So I'll make a note of that so you remember. This is the independent right. Anybody else writing? Right. I want to give you this note one time before we jump into questions, right? The equation of the regression line. This is X on Y, right? The other way around. Same principle, except the regression line looks like this now. The regression line looks like X is equal to C plus dy, right? And to get D is equal to sum of X, Sx over Syy, right? So a little bit different. And C is equal to X bar minus dy bar. So of course you need X bar and Y bar and D to find C. All right, so same principle. You're just switching around the X and the Y, right? This is now your independent. This is now your dependent. Copy down, I want to show you how it works. Anybody writing? All right. So let's try an example, right? Let's say we had to obtain an equation. Obtain an equation. I will do this first one, right? So go back, please. No. Obtain the equation y on x, right? Hurry, Celine, hurry. Very now, I wasn't going to tell you no. I'll turn it back one time. Ever. Next one, Celine, what you will do now time? After, before? After? Oh, amen. Oh, thank God, Celine. Right, just on here now. He didn't come to class today. They got people missing. I don't realize. So equation of the regression line y on x. Nice. So you want to get the equation. I will give you the x. In fact, I will do all the work and I'll just tell you, right? We will just talk about what we're supposed to have. So here's 5, here's 7, 12, 16, 20. Let's put 4 here, let's put 12 here, let's put 18. Let's make up our next value, 21. Let's put a value here, 24. Right. So we want to get a regression line for those 5 values. So if you look back at the formula, we need SXY. We need SXY and SXX. So to get SXY, right? Remember we needed the sum of x, y, right? All over n, sum of x by sum of y, right? And then here, we need the sum of x squared on n minus the mean squared. Are you okay with that? It have different versions. Which one I gave you? Anybody keep in mind which? Hold on, let me see if I gave it this one or I gave you. Oh, I gave it this one. Okay. Hold on, right? They both will give you the same thing. I think I put the n different in this one. Give me 1 second. I just want to change the value. So sum of I think I gave you this one instead. And here will be sum of x squared minus sum of x all squared all over n, right? Same formula, same formula. Right, so what does that mean? We need to get the sum of x. When I add up this, I'm gonna do this fast in my head, bam, 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 that's 60. Then sum of y, I'm gonna add up this fast here. That's this one harder, 79. Nice. What do we need again? We need x squared. We need xy. All right. So x squared, we squaring all the x values. So that's 25, 49, 144, 256, 400. Add up x squared there. I'll come back and do that just now. Xy is 20, 84, 12 by 18, that's 216. 16 by 21, that's 336. 20 by 24 is 480. And then I add up xy. Right? So sum of x is what? 1, 2, 3, 4, 5, 6, 7, 8, 874. Sum of xy is what? 4, 5, 6, 7, 8, 9, 10, 11, 1136. Right? So now for me to find sum of xy is 1136 minus sum of x is what? 60. All the following. So I just work it on and I plug it in the formula now, right? Sum of x is 60 or 69. Kai following this, and it's 5 values, right? When I work it out, I have 188. Kai following? Dexter. Right? The sum of xx, that is sum of x squared, which is 874 minus the sum of x, which is 60 squared all over 5. Hold on, let me just plug that in. I am getting 154. Well, you can just check back the values after to make sure, right? So now let's find b. Right? Remember, we're trying to find y is equal to a plus bx, right? So b is equal to sxy over sxx. So that's 188 over 154. 188 over 154 is 1.22, right? I'll even choose significant figures, right? Now, to get a, I need to have y bar minus bx bar. So x bar was what? Sum of x all over n. So that's 60 over 5, which is 12. Right? And then y bar is 79 over 5, which is how much? 79 over 5 is, right. So A is equal to 79 over 5 minus B, which is 1.22. Oh, I'll try not to round off, all over 12. So I have A as 1.15. So therefore, the equation is y is 1.15 plus 1.22 x. Everybody okay with that? Write this down, please, and check back my values, right? Anybody confused? Rajiv, Saskia? Rajiv, follow this. Saskia, you okay with this? Saskia, are you there? Copy down this, please, all you. Copy it down, tell me when you finish, and let's try one. I wouldn't give you one with too much values, right? What you have to pay attention to is if it's y on x or x on y. All right? Your homework is to learn to use a calculator to obtain this line, right? All right, go ahead. Do this fast. Come on, you finish, right? Anybody writing still? Nobody said the finish? Anybody writing this still? Finish? Okay, nice. Everyone finish? All right. So we're going to attempt, oh, by the way, anybody have the past paper 2016? They can send them a soft copy. 2016, paper 2. So I gotta take pictures now. If you have it, send them group now. Anybody have it? All right. Nobody have it? Well, you could just say yes or no, you know. Oh, gosh, boy. All right, so let's use this, right? Not the best, but we will use it. Since nobody have it. All right, so let's take a look at 2016 here. Right, so a used car dealer is investigating the relationship between the price of a particular model of car and its age. The following information was collected for a sample of 8 cars. Right, so they give it a year and the value. That's in thousands, right? So 2-year-old car carrying a little more, 3-year-old a little more, right? So you can kind of see a relationship. The older it is, the less it's valued, right? Right. So they give you some stats. You don't have to work anything out. They give you sum of x, sum of y, sum of xy, sum of x squared minus x squared, and sum of y squared, right? They were also nice to you, and they even gave you a regression line, right? So they gave you the regression line, and they gave you the correlation value, right? What does this negative 0.96 tell you? What does that say? Anybody there? What does a negative correlation value mean? Negative 0.96. We did this last week. Hey, somebody else could answer, please. Ka, we did this last week with Rajiv. What does negative 0.96 represent? Right, so negative, good. No, look back at the value. Remember, I gave you all a breakdown? I gave you all a breakdown, 1 to 0.9, I think, or 1 to 0.8 or something, right? I gave you all then 0.9 to 0.7 or 0.8 to 0.7, something like that. I gave you all a breakdown last day. And once the value is between 0.9 and 1, that's a very high correlation. Negative means it's a very high inverse correlation, right? So this is very high inverse correlation. You have that note? You have that note, Jude? I feel do write notes, you know. Right, Jude? You have that note? Where I broke down the correlation values here. Yeah, I gave it positive, and I told you all you have to do is just put negative on all the others or inverse. All right, so state one reason why the value of the car is a dependent variable. Why is the value of the car dependent variable? Simple answer. Why you all think why is it dependent variable? All right, good. Because the value of the car is dependent on how old it is, right? That's why it's dependent. So the value of the car, right? The value of the car is affected by the age of the car. So it means that the value of the car is dependent on the age. So if negative, so if it negative would be, yes, Saskia, if it negative, is just the inverse of what happens on the positive side. So between 0.9 and 1 is very high positive correlated. So negative 0.96 is very high inverse correlated. All right. Next step, they want you to plot, right? Calculate the mean value of X and the mean value of Y and clearly show the point, right? So I'm not gonna do the whole plot, right? But you're basically plotting 8, 18, and so on, right? So 8, 18 somewhere here, and then you continue to plot, right? So you plot and you plot and you plot and you plot, but you need X bar, Y bar. So you have to find X bar, Y bar, and then, right, show that point clearly. If they actually put a regression line, then the regression line is a best fit line that passes through X bar, Y bar. Okay, so make sure you remember that, right? Right, this question, they want you to plot it like normal and then show X bar, Y bar. You don't really have to show the line. Question didn't ask for that. They asked for a scatter plot, right? And then they ask you to show X bar, Y bar. Are you okay with that, Dave? Fair? Are you okay with that? Now, let's see what this regression line represents, right? So on the same grid as this draw regression line. So basically, you're coming back here, and to make it exact, because they give you the line, make sure it passes through X bar, Y bar, and whatever the y-intercept is. 112.26. So 112 will be like somewhere here. Make sure your line passing through the y-intercept on that, right? You don't have to go and figure out now what the y-intercept is. Sorry, where the best fit line is. It has to go through X bar, Y bar, and because you know the y-intercept, it has to go through A. Right? When you all have graph paper, you're good to try and do it, right? Now for the worded part, with respect to the data, explain what does minus 11.29 represent. 11.29. So here's what it represents. What it says is that for every year, remember X is years, for every year, right? And we have to be specific to the question, right? So what it's saying here is that every year, the value of the car decreases, or we know it depreciates, by a factor of 11.29, right? Right? So in words, that's what the 11.29 represents. It represents the factor, right? It represents the factor by which the value of the car is decreasing. If it had a plus sign, it would have been increasing. That's okay? So the minus 11.29 represents every year the value of the car decreases by a factor of 11.29. So it gives you an idea of what that minus 11.29 will do. So every year you add on, then that value of y will decrease by that factor, 11.29. Right? Use the regression line. Are you okay with this? This is very important. And notice I didn't give a general explanation. I gave an explanation based on the question we do in years and value. All right. So based on the question, you could just flip that around, right? Years and value. Next one. Use the regression line to obtain the value of the car when it's 7 years. So y is 11.226 minus 11.29 by x. X is 7 now, right? So y is equal to 112.26 minus 11.29 by 7. How much is that? That's in thousands, eh? By the way. That's in thousands. How much is that? Right, Rajiv got 33.23, right? That'll be thousands, right? All right, so based on this, after a period of time, your car have no value, right? After about 10 years, as it for your car there, no value. Okay, so nice. Last thing, interpret the value of the product moment correlation value R as it relates to the data. So R is minus 0.9, that was 0.96, I think. Yeah, minus 0.96. Right, so what we'll say here is a very high inverse correlation between the years and the value. Okay, so we need to understand what those things say. This question didn't ask you, but anybody could tell me in their own words, what do you think the 112.26 represents? Anybody? In your own words, what does that represent? Anybody in your own words? What do you think the 112.26 represents? Car, what do you think this represents? Right, very good. Who said that? Very good, Rajiv. So basically, see, right. So basically, when x is zero, that's like a brand new car. That's the price of your brand new car, 112.26. Right? Yeah. So that's basically the price of a brand new car. All right. So that's the value of a brand new car. So the value of the car when the age of the car is zero. So that means brand new, right? All right. So good. So that's a little idea of how to read the regression line. All right. So let's calculate one and read it. Please do it. Please, Ollie. I'm not doing this one. What I will do is I will let each person send my picture individually of what you have. Right? I suspect some people not doing anything. Kai, you have all the explanation down there? All right. So use it and calculate this here for me. This is 2014. Hurry up. It's the last, this is the only one that we're doing. We're just doing one and we're done. All right. So just do the summer, please. All the values there, find A and B, estimate, tell me what B is, and find R. So once you finish, take a picture of your working and send it from my WhatsApp. Nice. I have one so far. Jude, remember to do out, still do out the rest, part 2 and 3 and 4. Good so far. Right, sign your values. Car, so much you have. I'm gonna see it. Grand, so much you have now. I'm gonna see how it looking. Right, where some what you have now. Car waiting on you. How far you reach? Send a picture what you have, please. Who else are waiting on? Grant. All right. So time up. Let's take a look at the calculation here. First thing, right? So the sum of xy, right? I have 108.1, and the sum of xx is 184.1, right? So your b value, when you use the formula, your b value is 108.1 over 184, which is 0.587. And your a value, right? A value is your y bar minus bx bar. When you work it out, I have 7.57 here. So the equation is y is equal to 7.57 plus 0.587b. Right? Estimate the performance when the score is 37. So y is equal to 7.57 plus 0.587 by 37. How much is that? What you all got there? 29.3. Nice. Right? So when your aptitude score is excess aptitude score, right? Right. The performance score. Right, good. What does B represent? B is the value, boss B again, right? So B is the factor by which every 1 unit increase, so every 1 unit increase in the aptitude test, right? The performance score will increase by a factor of 0.587. And then you have to find a correlation value, right? What's the correlation value there? Right? Nice job, Grant. Anybody have a correlation value? Yeah, I have 0.44 around there. Right? What type of correlation is that? Oh yeah, this is to interpret it. What type of correlation is that? 0.44. Check back a little list I gave you. What's a correlation of 0.44? Right, good. A low correlation, or a weak, probably even weak. Right, but a low correlation between the aptitude tests and the scores. Right, and the lower it is, it means that the lower this is, it kind of means that this is not really a good predictor because the two variables are not related, not correlated. When the values are highly correlated, then this regression line carries a little more weight, a little more meaning. All right. Okay, so nice. So that's the way you interpret, and that's the way you work it out, right? Please remember, right? Please remember, Varun, sorry, little mistake. Please remember this, right? You have to look out for y on x. So if it's y on x, right? If it's y on x, make sure you use the right formula. If it's x on y, make sure you use the right one, right? All right. One of the things that you have to do for measure is scatter plot. You all don't have past papers. I thought you all had everything soft copy. All right. On the group of sending a question here is 2015. If you have it soft copy, well good. I want you all to do this for next day for me, please. Right? You'll need a graph, right? That's 2015, number 6B. Okay? Right? And then, well, once you do that, okay, that'll be the end of the regression and correlation, and then we go on to the real stuff. Right? The hypothesis testing. That's the last thing in this module. Okay? All right, nice. That's it. All right, so that's it. You all can log out. If anybody have soft copies, share them, right? I think I missed 1 or 2 of the years, but I will look and see what I have and share them on the group. Okay, so nice. That's it for today, all you. You all can log out. You have one question for homework. Please do it. All right, bye.